Hi, my name's Matthew Apps and I'm head of the Motivation and Social Neuroscience Lab in the Centre for Human Brain Health at the University of Birmingham. And today I'm going to be talking about how dopamine drives decisions to move on. So in everyday life, we often have to make decisions about whether we want to stay in our current location where we might be doing some things that we value, that we find rewarding, and travel to find alternative locations where we could do something different. So for instance, that might be as simple as deciding that you don't want to spend any more time in the kitchen, instead you want to go and watch TV, through to more serious decisions such as whether you want to stay in a particular relationship or whether you want to leave an international trading bloc. All of these things require us to think about what is the value of my current location and how does that compare to the alternatives I could be in. In neuroscience, we often think of such things as what we call value-based or cost-benefit decisions, where what we do is weigh up the costs and benefits of our current locations and compare that to the average value of all the alternative options we could be doing. And so if lots of the other things we could be doing are not that great, we might be willing to stay a bit longer. If the average value of other things is low, here seems a little bit better. On the other hand, if the grass truly seems greener on the other side, if lots of the other things we could be doing seem very high in value, then we might be more willing to switch and move on more quickly. And so in this experiment, we wanted to investigate whether the neurochemical dopamine might have an important role in these decisions. Previous research has linked dopamine to cost-benefit decisions, but had never examined whether it might be really important for making us think that the grass is greener on the other side. So to test that hypothesis, we created a new computer game-based experiment. Now in this task, you were told as a participant that what you'd have to do is to act like a farmer. You had cows that were situated in different fields, and what you had to do was across the day is to collect as much milk from those cows as you could. Now what you had to do in the particular experiment is you'd enter a field which looked like this. You'd have to decide when you should leave that field and spend some time traveling to the next one before you started collecting milk again. And so the milk was shown here in this milk pail. And what we did was manipulate the value of the current locations or the fields that you're in. So the way we did that is we had fields that gave you different amounts of reward or different amounts of milk. So there could be good fields like this one here, where this curve you can see here dictates the speed with which this milk pail is filling up. So in this condition, the good fields, you'd get a lot more reward than you would in this blue field here, the bad field. And so what that means is if you care about the value of your current location, you should stay longer in this type of field than you should in this type of field. But what we also wanted to do was manipulate the alternatives that you could be pursuing, the value of other things you could do, or in this case, the value of all of the other fields that you might be end up collecting milk from. So the way we did that is we had participants perform this task in 10-minute blocks in two different types of farm. So in the poor farm, 50% of the fields that they'd see would be the bad ones and 20% would be the good ones. And in the rich farm, 20% would be the bad ones and 50% would be the good ones. And so if you care about the value of the alternative things and that influences your decisions of when you leave, you should actually leave more quickly in this rich farm than you should in this poor farm, because you're more likely that the next field you visit is going to be a good one in the poor versus the rich farm. So first, what we wanted to do is test if healthy young participants made decisions in line with those predictions. So what you can see here is the data from 40 healthy young people where what I'm plotting is the average amount of time before they made a decision to leave in the 6 different conditions of the experiment, in the bad, the medium, and the good types of field, but also in the poor farm here shown in green, and in the rich farm shown here in gold. Now what you can see is people stayed longer in the fields that were going to give them a good high amount of reward compared to the ones that would give them a bad amount of reward. So they clearly cared about the value of their current location in their decisions to leave. But crucially, they were also considering the value of the alternative things they could be doing. So what you can see here is they left sooner in all of these fields in the rich farm compared to in the poor farm. So clearly, when the grass was a bit greener, they moved on a bit sooner. So next we wanted to test whether dopamine might have a role in these kinds of decisions. So we tested 29 healthy adults in a double-blind crossover design where they in one session took a placebo pill and in another session they took a cabergoline, which was a drug that manipulates the amount of dopamine available in their brains. We then got them to perform exactly the same task in each of those 2 sessions. And what you can see here is the same kind of plot as shown on the left-hand side, but now in the solid lines are the conditions where they've taken the drug, and the dotted lines are the conditions where they've taken the placebo. Now what you can see is there's only one condition that seems to be different between the on versus off drug behavior. And that is that when participants had taken the cabergoline, they left in all of the fields sooner in the poor farm compared to when they had taken the placebo pill. So what that means is when they took the dopaminergic drug, they seemed to treat the poor farm as if it was a little bit richer and left all of its fields a little bit sooner. So what does this mean? Well, what this suggests is that dopamine has a role in these decisions to move on. So when we're comparing the value of our current location to the value of the alternatives, if we boost people's levels of dopamine that's available in their brain, it makes them think that the grass is a little bit greener. And so they're more likely to move on more quickly if they've had dopamine boosted. Now, why does this matter? Now, dopamine has been linked to a whole range of neurological and psychiatric conditions, including Parkinson's disease, schizophrenia, OCD, and ADHD. And so we really need to get a handle on how dopamine changes people's decisions and how it makes people make decisions to move on from one location to another or from one situation to another, if we're really going to understand what are the symptoms that underlie these conditions. So a big thank you to Campbell Lahiron, who was the PhD student who's led on this project, as well as to the collaborators and also to the funders. Thank you.